Alright, we are live. Mic check. So here's another stream. This is day 7. So yesterday we were just reading this compute PBR maps function, our member function here, which has a complete pipeline in itself, a few shaders, and some other stuff like textures and stuff. And we were trying to figure out like how this command thingy works. There's a command system here, and how the whole like the whole rendering pipeline works, because this has a simple miniature pipeline in it, miniature renderer in it, and it actually renders the cube map for the sky from the panoramic texture for the sky. So we got some basic understandings of like things like these UAV barriers, and I don't know what they're called UAV, but they're just resource barriers. And yeah, we finally get to understand what root signatures were. So as I understand them, root signatures are just ways to specify like the input of the shader. So let's find some root signature. So this is, for example, a root signature, and this is how it's described. Let's see what you can find in the root signature. So root signature has some samplers in it. Static sample count. I don't know what that is. Root signature flags. Let's see what root signature flags are. Flag none. Local bits. Ah, ray tracing. I'm not getting into ray tracing yet. Like I can't even run the examples. I do not have a ray tracing RTX graphics card, so I won't be getting into any details on the ray tracing. But the rest of the code I will probably uh, read the whole shaders, everything. So yeah, let's get back to our root signature here and just examine what it exactly is. So it has a shader, bunch of shaders. I don't know. Yeah, a bunch of shaders there. So and finalist textures. I don't know what they are. I know about the samplers here. Static sampler count. I don't know what that is. And we have these flags here, which we just figured out that we don't really need, because it is for ray tracing. So a root signature is just how you bind the. It just describes what variable in the shader is going to accept the sampler. So we're saying that, for example, here we're saying there is going to be a variable named skybox sampler in our shader, and that is going to and I will be binding some texture to that sampler. So yeah, and here we're just telling the renderer to compute that uh, to give us a root signature given this root signature description, and it will just pass us back your root signature. We will use that root signature later on to like. So here we put it in a descriptor set, all our descriptors. So we get few root signatures, we put them all in one descriptor set, seemingly. So yeah, so this is just describing how often that variable in the shader needs to be updated. So we use, I don't know how they're doing it, but these root signatures usually are like, let me find the shader for this. This is the skybox shader here. Let's see if we can like panel to cube. Yeah, yeah. It's a compute now. Compute shader. How is that? Interesting. Anyways, so yeah, I'm also checking the Vulkan version of these, since I'm more familiar with the GLSL syntax rather than HLSL. H2D. So yeah, so this is that sampler we just described there in this. Interesting thing is we are adding the same signature twice here. I don't know why that is. And why is this per draw? So the update frequency of this is only once. These are none, and these two are per draw. But why? Why are we generating MIP maps every time? Let me check that compute shader again. Interesting. HLSL made in Vulkan? I believe this is Vulkan syntax. So we're just getting the invocation ID here. We're passing it to our HLSL main here. What that is doing is Windows down root constant dot mip. What is root constant? Root constant block and backslash. Ah. Oh. So yeah, now I understand why we're setting the update frequency for these to per draw, because it actually, we're drawing into them. Sky Mips. Ah, like let's assume a root signature is just defining how the input for our shader is. So it is actually, where's my shader? Yeah. So it's actually just telling us what these are going to be. And this, so it's just describing these, which are the input to our shader. And so I'm assuming that we only have one. We should have one of these, like let's say this root signature here, panoramic to root signature, panoramic to cube's root signature. It is being defined as being made from this descriptor here, which is panel root descriptor. And what it describes is just that I have one sampler, and just it says that I'm using that panoramic cube shader. Okay, that's fine. Keep using that. And then it just says that I have one sampler. Here's the sampler's name, which corresponds to the this year. Alright. And then it says that this is my sampler. There's an actual definition of the sampler. It is null at the moment, but someone somewhere initializes it. Yeah, we don't care for that for now. And then it just creates a sampler based on this description. And then it uses it several times. Like it not only uses it for this here, it reuses it. I don't know why it reuses it for our output. These are our output textures. I don't know why it uses it for that. Like who cares? Who even cares? That is weird. And it's not like we're I'm missing part of this. It's not like I'm missing any part of this. It is just being initialized here, and these are all the changes we're applying to it. That is kind of weird. Anyways, we will get back to this. I have no idea what that is. So, and from there we get a pair of descriptor sets for panoramic to cube map. And then again we set some stuff here, some parameters here to those descriptor descriptor sets, which is that it is that we are going to have like parameters. Where is this initialized? This is the first use, no, this is the second use. Right, we're just carrying on a whole lot of states. This is making the code really difficult to read. Anyways, we're just saying that we have another source texture as input to our shader. This is not a good example for shader because this is a compute shader, and I'm not really good with those. I don't know why they're not. Yeah, that kind of makes sense. Why not to actually draw anything? So yeah. Anyways, let's get back to this. So it is just describing that this corresponds to this initiator, this SRC texture. So it's just saying that we have a SRC to the SRC texture. Our binding number is 3. I don't know what this binding number is used for, because we are obviously doing reflection. So that's described in this one. We'll go through the pipeline and we will get back and read this panoramic to cube uh, completely and get a whole image of what it actually is doing. So yeah, this is adding that parameter, and then we come here and we add a bunch more. So here we are adding, here this corresponds to this here. Where is it? Corresponds to this. So it's a 2D image array. Our result is going to be in this. And we're just describing the parameters and updating them one by one. Interesting thing is that one of the elements of this takes an index, and another index there. Like, I do not see how this sampler here, this sampler that we put in these, like how this sampler helps with that, I have no idea, because we're just setting a sampler there and we're using it in here, and we're using that in two places, in our source and in our destination textures. I don't know how that helps in any way, but yeah, that's what we're doing. Okay, so yeah, we were here, we were doing the MIPS, and we're using that for our MIPS, root constant, root constant data pad. Command push constants, panoramic cube root signature. So this one here, this corresponds to this layout push constant. Just alright, so yeah, we're using that is to send our data to the shader, and that is using this. I will recommend any kind of serialization like this. Oh, someone is in the chat. Sorry, I didn't notice that. And yep. So let's see, let's read further on this. I don't know why this had to be done like 11 times. I'm kinda thinking that this didn't need to be done 11 times. Since it's a root constant, like this is not an array, I could do it like once. Let's try that, shall we? Let's put this over here. So I don't really like this kind of code, but that is what we have. Actually, I may like do other renders after this one too, but I really like wanted to get to know this code. let's get this built and see what actually happens. I believe that that's gonna work just fine. I don't see any reasons as to why we would have to like do that 11 times. Unless we crash right now. So we're already 20 minutes in. I'm really hoping to get to know the code enough that I can get, yeah, this works pretty well. What and one thing that I don't think we're ever going to get too close to these to the skybox shader. Why do we have a bunch of mip maps for it? Well, I believe mip maps work. Yeah, of course work. By the way, I love that building. That's the lyrical building there. I love that. Alright. So yeah, this seems to have worked just fine. I believe it should have. There was no reason not to. So yeah, it works. We just move this outside. Yeah, I was saying that I'm just trying to get enough understanding of the code so I can actually modularize it. So I will try to modularize this one example here, and after getting like enough knowledge of that, uh, I will just try to modularize uh, the engine code as well, and I'm hoping to both get the code cleaner and get some performance improvements and stuff like that. I also believe that at least this one example has a bug in it, a memory corruption. I will try to fix that as well. So, yeah, we were just saying what this does, and we figured out that this part is just updating these values in our shader. I don't know where this is updated, but maybe this is just set by the shade by the shader by the GPU. So let's read the shader itself. I might be able to later on add a plugin to highlight my shaders, but for now we're stuck with this. So this is our pi, this is our inverse A tangent. So right, this is our inverse A tangent. I don't know what that is. Pixel offset is 0. This is our third position. That is there. This is the number of MIPS we're going to do, and here is the code. So it's just getting the MIP size. Is there a goto in this? I'm assuming that oh. So they're not looping, I believe. They're using the thread position here. So multiple threads are going to start running this, and each thread is going to have a three-dimensional ID, which is this DT ID. And using that ID, it will just figure out which level of map to compute, as it does here. I believe that is what's happening here. So let's see. We have thread position X, and the X is over map size. Okay, so these are just wastes for us. Other than that, if not, it is going to start generating our route maps. So if it just came in, it had positions in the route map here, in the texture size. So this depends on a lot of parameters, I believe. So what if what if our position, our X position, uh, is not going to be big enough to like fill all the map? I don't know. I don't know what will happen there. But so what else are we doing? So the floating point with position X, we're adding that by half and doing this. So this is just getting the coordinate of the center of the texture, I believe, a pixel. So this shader is going to compute this pixel. This thread, the thread that just came in, is going to compute this pixel, and that's our superior direction, which is going to be computed here, I believe. So the superior direction is going to depend on this texture coordinate. Hmm. What is the difference in these? Why do I not get the difference? Oh, so so we have six faces on the texture on our cube map. So what is computing our mid level? How are we deciding which MIP we're using? As our MIP size. Oh, so that is what that was. Oh. With constant data. So I just missed this one. So yeah, I caused bug there. So that's why we have 11 of these, and that's why we're dispatching it every time. Shouldn't there be like memory barriers here? So I think we just assume that we're not going to write on our on other uh, faces of the cube map while we're writing on the rest. So that is what that is. And yep, so that is how this is going to work. So I believe every dispatch we're doing, we're just pushing whatever that we have in the list on the queue on the GPU to like start processing it. And we're taking advantage of the fact that we have a three-dimensional space on our thread thread ID space. So I'm just wondering what would happen if our thread space was like smaller than our texture space. Like what if our z parameter was always less than like 4? Then I guess one of the faces wouldn't like draw. So I believe we have to like mention it somewhere that what kind of a draw we would like. So here it is, I guess. So when we're dispatching it, we're saying that yeah, bitrate group size. So here is that thread per group. Uh-huh. What's happening here? So this is just calculating the width of our texture, the map, and then we're alright in that. Interesting. What is the result of that? I think we're missing something else here. Some other parameter should be here that we get. Like from what I understand is that this is just saying that each pthread group is going to like compute like a batch of this texture. That's what I'm understanding from here, from this code. Well, or maybe not, or maybe I'm understanding it incorrectly. What's this? Number of threads per group. I believe I need this many threads, right? And these are the number of threads per group. So maybe I'm just saying how many groups I need. Maybe that is why what I'm saying here. Yeah, they are group count. So I'm saying that I need this many groups. But isn't this not enough? So I'm just assume I think that these are assumed to be a power of 2. Otherwise, like the remainder is going to screw things up. Also, why 6? Shouldn't this be like 6 divided by number of threads per group? Let's try this. Shouldn't that be like this? Okay, it definitely shouldn't be like this. This is about this is extra. Did I just add another extra closing parentheses? Yes, I did. Alright, so this seems to be working. I couldn't be sure though, could I? What if we just rendered one of these, like half of these maps? So I know I'm going to render just the 10th. Yeah, it seems that was what that was that was what's what it would that's what happens. And interesting, they have global illumination as it seems. It is probably big global illumination, but it is global illumination. Interesting. So how can I make sure that this works here? So few things come to mind, like why this part of the code? Why this? Or why is there not an else statement here? Those are my questions right now. Like, let's get this code back to normal. Let's try to remove this if statement here. This is just telling me that if the x and y elements of my thread position is out of the map, don't process it. But given the fact that they never are going to be, I can remove them. How am I saying they're never going to be? From this. They will be in this case, in this one case. There will be out of my texture size. But hey, if I have a texture size of 0, I don't care. Do I? That works just fine. So at least I believe this is how it should be. It of course does work. Like, oh yeah, it works. But that did actually work. Because if it didn't, like, I'm pretty sure if it didn't, I wouldn't have some of the sides. I have all the 6 sides here. So yeah, it is using the z parameter just to yeah, it is using that z parameter to decide which side it is going to render. So let me do a brief like explanation of what happens here. So on the GPU there are like three like threads, the computing like the computing, I don't know what to call them. The computing units are addressed with 3 elements, 3 vector of 3 integers. So each computing unit is going to have like one x, one y, and one z, and one z. So the on each invocation of that thread, that like let's say conception like that conceptual thread, that thread is going to be assigned an ID based on those 3 integers, and that is our DTID here. And we're trying to like use take advantage of that by like telling each like I'm gonna decide based on the z parameter like which face I'm going to draw. Based on the y and x parameters, I'm going to decide which point in on which face I'm going to uh, process. So that is just the mapping of this three-dimensional space into uh, my cube map coordinates, which is happening here. And then of course I'm going to, after that I'm going to like map my, yeah, this is mapping mapping the coordinates on each face to the UVs. And after that is just going to read that UV like images store here. Maybe to read that, blah blah. Load. Yeah, we're reading the texture based on this and this map of that texture we're reading, and we're just storing that into this destination texture. So this is a simple shader here. And of course I could do like things like this. Let's say, let's see, like multiply this by, they said this automatically saved that, or did it? It did save it, but nothing seems to have to take that. Oh yeah, I am not. This is the Vulkan version, so I am on E3D. I will compile this project on Vulkan next time, since I'm more familiar with GLSL-like syntax rather than the HLSL-like syntax. I'm not sure if it's going to be any different than this actually, but yeah. So that's how this shader works in general. Like I didn't get into too much details, like why the A tangent of this and the arcsine of this. I didn't like get into those details. You'll get you will not get to that those details. Those are just maths. I need pen and paper to like prove like they work, but they work. They definitely do work, and just this like undo all our modifications here. Let's get back to the 3D12 version, which is what I'm compiling at the moment. So it doesn't seem to be any different here. And what I'm going to do is remove this, which I believe is not going to cause us any problems. But other thing that I noticed that we can play around with, just to like see how these are actually taking action. So there was a minor connection issue there. Let's see if the fun part of this was actually okay. You didn't get the fun part, I guess. So what I did was to like just simply, let's do that. No, yeah, was to simply divide this by 2 just to get the half of it. But yeah, I'm rendering just half of each of these cube faces. So that is how this is actually working. Alright, I guess I have good idea of what this is doing here. So that was fine. The rest is just kind of the same. Differentiators though, and obviously given differentiators, you'll have different of course root descriptions. However, one thing that here, right, sorry guys, we have some connection issues again. I'm just hoping that it gets better. I don't think it is going to get better. Yeah, it did not get any better. I hope that fixed it. We are back on. Uh, yeah, so I was saying that I've seen some like specular pipeline somewhere in the like in this code. I'm going to figure out what that does too. Let me just figure out where it was, and I will be able to get to that as well. So this kind of code design is pretty difficult to document. Like the interfaces are like extremely complex. I cannot remember where I saw that specular pipeline. Let's get that as our search parameter and see if we can figure out where I've seen that. This is interesting shader here. I will get into that as well. Let me just find what a shader, what we have in the shader. Where is the shader here? You guys see shader? No, I'm not going to come here. But that is trouble. Shader. Irrigance shader. Do we have in a shader? What about the pipeline? So this is what I guess. Yeah, this is where I saw that. I believe. Did I? No, this wasn't. This wasn't where I saw that. Let's search specular here. Specular. Nope. I don't know. I believe I saw something like that last time. Either I'm going crazy, or yeah, I don't know. I don't know. I do not know. I do not know what I've seen. Let's go to our descriptor here in pipelines. Don't know. I don't know. I don't know what I saw yesterday. Okay, let's keep it interesting. That's going to be really boring and slow. So yeah, from what I understand now, it should be perfectly fine just to define our root signatures wherever we want. So let's start by this. Our skybox sampler here. Why do we have to like do that every time? Where is my skybox sampler here? What the hell is just going on? Where is this one defined? Oh god, so slow. Our connection is fine. I'm going to give this stream 10 more minutes just to figure out what it is that I'm going to do next stream. We'll then just do the rest tomorrow, I guess. So what I'm trying to do is just encapsulate everything that is related to this that simple panoramic to a skybug to a cube map uh, part of the code. So we have an in out, since I don't know what this command is doing here, like what state it keeps through the process here and what it doesn't. This command is going to be our in and out parameter for we would have a function uh, let's say I add a lambda here. Let's name this prepare panorama to cube map command. So let's say I'm going to add that lambda here. That is going to be that is of course going to take in a command. Let's keep all the main information here. So yeah. So this is a two-dimensional array there. I'm wondering why whether that's an array, that's an array texture there. I'm wondering if this call will put a barrier on all of them or not. So this is the signature of that. Buffer barriers. Render target barriers. Huh. My Visual Studio is too slow today. I don't know what happened. I don't know why. Oh, come on. Just give me the signature here. So yeah, this is this. We have three kinds of barriers. We probably are using only the texture barrier here. We have render target barrier, buffer barriers. Get back to our code here. So I believe this is what we need here. And all that, right? I believe that is all. So let's move this here. Let's ask Visual Studio to maybe format it for us. Thankfully it did not format it for us. Why the hell not? What is this? Is there an error here? Yeah, there's an error here. Yeah, I missed the closing parentheses here. That is fixed, and that is our formatted code right there. Alright, so I'm going to call this exactly where I called it before, which is here. There, right, reside before. That is just to make sure that everything is going to go just fine. And we have pcmd here, pointer to our command that is being called there, and we are missing few things that I am not at all concerned about. So, Planet Cube pipeline. This could simply just be moved in. Planet Cube pipeline here. That is the first place that it is being declared and is being used here as well. Which I believe after this it has served. No, I could not be sure about that. I was trying to like move it here. I could not be positive about the actual correctness of that code. So this actually has to leave outside. I'm not sure when it is possible for me like to delete these. So that may be one part of the interface that would be good. So like it would give me some future parameter here. So this is like when I dispatch here, it would give me some future parameter or callbacks or whatever that I would be notified about the actual completion of the task I've just dispatched here, and knowing that I would destroy my pipeline there. Anyways, params is going to be easy. Just it is an empty parameter here. Let's see where it was defined. Don't tell me this is a global variable. That would be awful. Okay, yeah, that is simple. So that is our params here. Keeping it all local as much as I can. Even if we cannot make this our member, we definitely can create it here. And I am going to capture it, of course by reference, because I'm setting a value to it. Why am I getting walked at so much? Pipeline settings. Let's see what this pipeline settings thingy is. So I'm just going to bring in everything little by little, like this. As we figured out, this needs to be this needs to leave. Same as this, I believe all of these need to leave here. Leave here. I will just take these inside, I guess. But those, maybe these, yeah. Maybe these. I could copy these inside. Why not? Or these actually, this one is used, I believe, used outside the code. Let's see where this one is used. Load describe box panoramic texture. No, blah blah. This is inside our lambda here, and there's this one. Okay, that's your wind resource. So since I'm not sure whether these are being copied or not, I'm pretty positive they are not being copied, right? Like my texture is not going to be copied. Maybe that was the reason we were having a crash, like on our create pipeline thing here. Create pipeline. So I don't know, maybe on third day or fourth day, we started like getting some of this skybox pipeline here. So this is the pipeline that actually renders the skybox itself into our scene. And what we did was we did this. Huh? Did we? What's that what we did? Oh yeah, of course that was what we did. So what bugs me right now is that how these lifetimes are being managed. Like let's get back to our code that we're just modifying so we're more familiar with it. So let's say that I come here, I'm doing this. Let's firstly like try to simply like simply try to like get all our errors fixed. I'm probably going to like try to capture capture all of these. This could be captured. Save this. Okay, IntelliSense. I'm just waiting for you to understand what I'm doing. Panel Skybox, Panel Skybox. What is this? Panel Skybox. Let's see. So this is the texture we just loaded. And yeah, I'm going to capture that as well. This is going to be a long line here. So just to avoid that, I better start breaking the lines here. And I don't care about the order of captures. Let's capture them, whatever. I'm capturing that by pointer. Because of this, I don't know why that is so. I don't know why that is a pointer to pointer. This is our what is this? This is our I believe global variable. But that's alright. So this code should just work. Should just work fine. If it compiles, of course it would. I guess I need to capture these. These are not global. Ooh, we have this. Where is that? And why am I having I'm encountering a problem with that max function? I believe this is a this is a function. I believe that, but I'm starting to doubt it. Let's get carried away with that. Let's just figure out what this is. Alright. This is just a footer. Why not auto this? So, um, I could get a const there, but I am not. So that's why I'm starting to doubt, like, almost auto everything. So this, as I believe, this is that, right? We have a bunch of uint32s. Let's put an student before behind that. So let's say we have this code, like if I copy, I change this to auto here. If I change that to auto, I am going to miss this const here, most definitely. So that is one thing there. And then these are our are these yeah, these are just our inputs. I'm just putting it right like that right there. This code is getting complicated, but like this is not nice to read. This code still sucks. Like how am I supposed like say this is not a line of my code? It definitely looks like a line of my code. My body of lambda. Let's compile this. I'm noticing we're out of time. Skybox simply skybox size. Is this our problem? What is it saying? Cannot be implicitly captured because no default capture mode has been specified. Okay, I guess I will capture those. Why not? Let's just capture these. Where is my lambda? Here is my lambda there. Oh, okay, no. No, not like that. Not like that. Come on. Geez, Skybox. I need to hurry. Geez, Skybox. We are already 10 minutes over our usual time. GS Skybox and what else? GS Skybox size and MIPS. Size. Oh, come on. Can I even type? And MIPS. That is what we're missing, right? Let me see. Oh, these are globals. Where are we trying to capture them? Properly. There's nothing there. Let's see what the error is. Thankfully, Visual Studio is way too slow today. It's undefined. Oh, oh, oh. Is this going to work? Can I get a format on that? I need to learn these short keys. Let's just get this to compile. We will continue on this tomorrow. I'm just hoping that we don't crash. And we did not crash. That is nice. Alright. Alright, yeah. We will continue on this tomorrow. Thank you for watching.